Welcome to Chemical Science Made Simple. I am Wisdom Benjamin. In our previous class, we looked at how we can write the names of the compounds of alkanes. And in today's lesson, we shall be considering how we can draw the structures of alkanes from their names. If you're here to subscribe to our channel, please do so. And don't forget to also like and share this video. To draw the structure of any alkane, it is very important to consider the parent's name of that particular alkane. You can get to know more about this in our previous video, where we identified the number of carbons and what they signify in an alkane. The name of the alkane must be looked at, and each segment of the name we must try to find out what they really mean. The first thing to consider in drawing the structure of an alkane is to identify, like I said, the parent name of an alkane. After that, we write out the carbon chain according to the number of the carbon in the parent's name. Then we identify the substituents, if there is any, and insert them in the carbon chain according to their respective positions. And for our information, the positions of the substituents are the numbers that appear just before the substituent in the name of the alkane. Then we fill up the remaining spaces in the carbon chain with hydrogen atoms to make sure that every carbon in the chain are tetravalently bonded. We are going to be looking at some examples to be able to explain what we are talking about for better understanding. The first example we have on the board is butane. Now, from our previous class, we understand that but signifies 4 carbon atoms. Now, the N simply means that this compound is an alkane. Now, butane, we are expected to draw the structure of butane. We'll start first by identifying it as but, which is 4 carbon. Then 4 carbon. This is my 4 carbon. 1, 2, 3, and 4. Now, if you look at it as a butane, there are no substituents in this compound. So we simply fill up all the carbons with our hydrogen. Hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now each of the carbon have hydrogens on it, and each of these carbon are tetravalently bonded. What I mean by tetravalently bonded, if you look at every of these carbon, carbon 1 has 4 bonds attached to it. 1, 2, 3, 4. For this carbon, 1, 2, 3, 4. For this, 1, 2, 3, 4. For this last carbon, 1, 2, 3, 4. This simply means tetravalently bonded carbons. So this is our butane. Now, looking at the second example, we have 2-methyl butane. We are to draw the structure of 2-methyl butane. First of all, the parent name also is butane, which simply means 4 carbons. Now let me clean up these hydrogens here, since we are still working with butane. I still have my 4 carbons here. 2-methyl butane. The parent name is butane, 4 carbons. Now we have written out the carbons in the 4 carbons. Then there is a substituent in this butane, and that substituent is what? Methyl group. This is simply what a methyl group looks like. CH3 is a methyl group. Now, and where is it located in this butane? It is located at the carbon 2. Remember I said when we started that the position of these substituents appears just before their names. So the 2 we see in this name simply means the position of this methyl group in this butane carbon chain. So we can choose any part of this chain to count from, either right or left. Now let me start from the left. Let this be my carbon 1, and this is carbon 2, carbon 3, and carbon 4. Now at carbon 2, there is a methyl group. It doesn't matter if it is up or down. And that seems to be the only substituent we have in this compound. Then we fill up every other carbon, every other space in the carbons with our hydrogen atoms, so as to make sure that every of the carbons are tetravalently bonded. Now this becomes our 2-methyl butane. 2-methyl butane. The third example is quite long, but it looks as if it's going to be a tedious one, but no. If we can follow these rules, it will be as simple as A, B, C to Z. The positions are clearly written, the substituents are there, the parent's name can as well be seen. And what do we have? We have 2,2,4 tribromo 3,3-dichloroheptane. The parent's name comes last, of course, we see it, heptane. And from our previous class, we saw that heptane simply means 7 carbon atoms. Hept, 7 carbon chain, 7 carbon atoms in a chain. Now, that is the first thing we'll write. Number 3 example. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now again, let this be my carbon 1. I go from left to right. 1, 2, 3, 4, 5, 6, 7. Now in this heptane, the parent name have been identified, the carbons have been written out. Then let's identify the substituents and their positions. In this heptane we have 2,2,4 tribromo. Now, of course, we know why bromo is before chloro. In our last class, we considered alphabetical arrangement. So B always comes before C. Now, at carbon 2, 2, and 4, there are 3 bromo. Why is it 3 bromo? We said tri means 3. So at carbon 2, there is a bromine atom. In the same carbon 2, there is another bromine atom. Then in carbon 4, another bromine atom. Now the bromine atom, we are done with it. Try 3 of them, 1, 2, 3. Now let's go back to the chlorine. At carbon 3, there is a chlorine atom. Again, the same carbon number 3 carries another chlorine atom. That is why we have di. And that is the end of our chlorines in this compound. And that also is the end of the substituent that we have in this chain. What then remains is for us to fill up every space in the carbons with our hydrogen atoms. Now we have the compound well written. This becomes our 2,2,4 tribromo 3,3-dichloro, that is 2 chlorine atoms, dichloroheptane. 2,2,4 tribromo 3,3-dichloroheptane. And the last example we have here is a hexane compound. And hexane Of course, from the name hex signifies 6 carbons. That is not the last example that we can consider. You can consider as much examples as possible, but following this particular method, you can name as much compounds as possible. Number 4, we have 3,3-dibromo, 1-chloro, 4-ethyl, 2-methyl hexane. This is more complex than the previous. Now, but the most important thing is identifying the parent name, which is what? Hexane. Now, hex is 6 carbons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Again, I count from my... Okay, let's count from my right this time around. 1, 2, 3, 4, 5, 6. This becomes my direction of counting. Now, just like the previous example, at carbon 3 and the same carbon 3, there are what? There are 2 bromine. That's why we have 3,3-dibromo. Remember, I'm counting from right now. At carbon 3, these are carbon 3, we have a bromine atom, another bromine atom, all in carbon 3. 3,3-dibromo. So bromine has been what? Has been identified and has been inserted in the carbon chain. Again, at carbon 1, there is a chlorine atom. That's why we have 1-chloro. And where's my carbon 1? Of course, it is the first one here. I'm counting from my right. So at carbon 1, there is what? A chlorine atom. Again, at carbon 4, there is an ethyl group. What is an ethyl group? This is simply what ethyl group is. CH3, CH2. Ethyl. Ethyl is simply when an ethane loses a hydrogen atom. Ethyl, ethane. For ethane, we have CH2, CH3, CH3. But for ethyl, one hydrogen atom is lost, so we have CH3, CH2, and ethyl is a substituent. So at carbon 4, there is an ethyl group in this compound. So this is carbon 4. Then I insert my CH3, CH2. This is what? This is my ethyl group. CH3, CH2. Then at carbon 2, there is a methyl group. This arrangement simply is just because of the alphabetical arrangement. You can see B comes before C, C comes before E, E comes before M. So at carbon 2, there is a methyl group. A methyl group at carbon 2. And that is the end of our substituent. The next is simply to fill every space remaining with our hydrogen atoms. Like we did also in the previous example. Hydrogen, hydrogen, hydrogen comes here. Hydrogen, hydrogen, and hydrogen. Now, this is 3,3,3-dibromo, 1-chloro, 4-ethyl, 2-methyl hexane. Now, this is the longest chain. This is the longest chain here. 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6. In whichever way we go, at carbon 4, there is an ethyl group. Carbon 4 ethyl, carbon 4 ethyl, and the longest chain is 6, which is hexane. Therefore, the name 3,3-dibromo, 1-chloro, 4-ethyl, 2-methyl hexane. Many other examples can be used to further explain the structure of alkanes. You can try more examples, simply follow these simple rules, and of course, you arrive at a very good answer. Don't forget to subscribe to our channels.